Hello students, today we will discuss about the isolation method of glycyrrhetinic acids and rutin. Basically this glycyrrhetinic acid and rutins are obtained from the drugs which belongs to glycoside category. Basically this glycyrrhetinic acid is obtained from the licorice, whereas this rutin is obtained from the Ruta graveolens. So we will discuss in today's class about the isolation and extractions method of these two compounds. So if you see in this slide that introductions about the glycyrrhiza from which we can obtain the glycyrrhetinic acids, and it is commonly known as the licorice, or we can say that sweet wood. And if we talk about the biological source of glycyrrhiza, basically it's obtained from the dried, unpeeled root and stolons of Glycyrrhiza glabra belonging to family Leguminaceae. Geographically, it is commercially cultivated in the Spain, Sicily and England, and the major active constituent of glycyrrhiza is glycyrrhizin. And from this glycyrrhizins, on hydrolysis, glycyrrhetinic acid is obtained. So introduction part of this glycyrrhiza is that it is commonly known as the licorice. You have to remember that it is licorice, which is also known as the glycyrrhiza, and botanical name of licorice is the Glycyrrhiza glabra, and it's belong to family Leguminaceae. And the major active constituent which is present in the licorice is known as the glycyrrhizin. And chemically this glycyrrhizin is pentacyclic triterpene saponin with two glucuronic acid units which are linked at the 3 beta hydroxyl position. Okay, basically it is the triterpene saponins and pentacyclic. Pentacyclic means it consists the 5 rings in their structure. So basic moiety, actually if you see the saponin structures and steroids structures, you will find that the basic moiety present in the structures of this type of component is cyclopentino-phenanthrene nucleus. Cyclopentino-phenanthrene nucleus is the basic moiety which is present. And actually glycosides are the compounds which consist two parts. One is the sugar portion and second one is the non-sugar portion. Sugar portion is known as the glycon part, whereas non-sugar portion is known as the aglycon part. So this triterpene saponin is the aglycon part. It means it is the non-sugar part, and it is attached at the glucuronic unit, where it is attached with the glucuronic acid by the link at the 3 beta hydroxyl position. Okay, and this glycyrrhizin is commonly known glycyrrhizic acid, or we can say that the glycyrrhizinic acid. It also known as the glycyrrhizic acids or glycyrrhizinic acid. Okay, so you have to remember always that chemically glycyrrhizin or glycyrrhizic acid is pentacyclic triterpene saponin, and chemically it is known as 18 beta glycyrrhetinic acid 3O beta D glucuronopyranosyl 1,2 beta D glucuronide. Okay, 18 beta glycyrrhetinic acid 3O beta D glucuronopyranosyl 1,2 beta D glucuronide. It is the chemical name of this glycyrrhizinic acids or glycyrrhizic acids, and this glycyrrhizin is the natural sweetener which is 50 times more sugar in nature in compared to the sucrose. And most important point about this glycyrrhizin is that it has no caloric values. Okay, there is no caloric value of this glycyrrhizic acids, or we can say the glycyrrhizin. And if we talk about the pharmacological activity which has been reported for the licorice because of this compound is anti-inflammatory, anti-ulcer, anti-allergic, antioxidant, anti-tumor, anti-diabetic, hepatoprotective activity have been reported for the licorice. So important point in this slide is that you have to remember that glycyrrhizin is chemically pentacyclic triterpene saponin, and it is connected with the glucuronic acid units. It means two glucuronic acids are present which are attached at the 3 beta hydroxyl position. Okay, now if you see the structure that glycyrrhizic acid, so I am saying that glucuronic acid, two glucuronic acids are there which are attached at the beta hydroxyl positions of this A glycon part, and this A glycon part is the pentacyclic triterpenoid saponin. We are saying that pentacyclic means it consists the 5 rings, 1 2 3 4 5. So this is the pentacyclic triterpene terpene saponin. And if you see the hydrolysis of this glycyrrhizic acid, it will form the glycyrrhetinic acids and as well as two molecules of gluconic acid. So on hydrolysis of glycyrrhizic acids, it will give one molecule of glycyrrhetinic acids and two molecules of gluconic acid. So it is all about the chemistry of this glycyrrhetinic acids or glycyrrhizic acids, or we can say the glycyrrhizin. And actually this glycyrrhizin occur available in the form of the salt, and there are so many salt forms are available commercially. For example, calcium glycyrrhizin is there, disodium glycyrrhizinate is there, monoammonium glycyrrhizinate, potassium glycyrrhizinate, and magnesium glycyrrhizinate and ammonium glycyrrhizinate. And if you see the solubility pattern of this drug, so you will find that it is freely soluble in the hot water, alcohol, whereas slightly soluble in ether. However, its salt in the form of ammonium. So we can say that ammonium salt is soluble in water. It means it is soluble in the cold water because it is freely soluble in hot water, but its salt in the form of ammonium salt is soluble in the water. And this ammonium glycyrrhizin gets inactivated in the acidic medium because of the precipitations of the acid, and the pH should be less than 4.5. So at that conditions, this ammonium glycyrrhizin becomes the inactive because of there will be the precipitations of the acid. Now next is the extractions, or we can say isolation method of this glycyrrhetinic acid. So we will take the drug and we will convert into a powder form. The powder should be in the coarse form and it should be packed in a Soxhlet apparatus, and we will use the chloroform as a solvent. Okay, so first of all we have to collect the drugs. We will dry under shade, completely dry the drug, and then with the help of that grinder or some machine, we will convert this drug into the coarse powder form. Then this coarse powder we will wash with the chloroform, a small amount of chloroform. After that we will pack in the Soxhlet apparatus and we will make up the volume whatever required as per the monograph. Okay, whatever the procedure is there, according to that you have to take the quantity of the chloroform and specified quantity of the chloroform for specified amount of the drug sample. So you will extract till the complete extractions, followed by the filtrations. After filtrations you have to discard the filtrate. Okay, then you will discard the filtrate, and whatever the mark is remaining behind, it should be treated with the 0.5 molar sulfuric acid for few hours. ओके, यहाँ पे किया क्या आपने कि ड्रग सैंपल लिया, उसको आपने पाउडर फॉर्म में कन्वर्ट कर दिया, कोर्स पाउडर फॉर्म में कन्वर्ट किया और उसको आपने क्लोरोफॉर्म के साथ एक्सट्रैक्ट करेंगे आप सफिशिएंट टाइम के लिए एज पर द ऑफिशियल मोनोग्राफ और ऑफिशियल मेथड्स जो आपके पास अवेलेबल है उसके अकॉर्डिंग आप इसको एक्सट्रैक्ट करेंगे। अब जब आपका एक्सट्रैक्ट कंप्लीट हो जाएगा उसके बाद आपने क्या करना है, एक्सट्रैक्ट को फिल्टर करना है। फिल्टर करने पे जो आपको फिल्ट्रेट मिलता है उसको आपने फेंक देना है और जो ऊपर का जो प्रेसिपिटेट रहेगा या मार्क रहेगा वो आपको यूज करना है एंड यू विल ट्रीट विद द 0.5 मोलर सल्फ्यूरिक एसिड फॉर फ्यू आवर्स। देन followed by the filtration, and extract the filtrate with 3 portions of the chloroforms. Now what you will do that you will filter that extracts and filtrate. You will again you will take the different 3 portions of the chloroform. मतलब आप एक बार आपने एक्सट्रैक्ट किया, उसके बाद आपने फिल्टर किया, फिर उसके बाद जो मार्क बचा उसको दोबारा से आपने क्लोरोफॉर्म के साथ एक्सट्रैक्ट करना है, फिर उसको तीसरी बार फिर करना है। तो आपने क्या करना है कि 3 बार इसको क्लोरोफॉर्म के साथ आपने एक्सट्रैक्ट करना है। ओके, नाउ after that you will combine all the chloroform extracts and distill off the chloroform. After sufficient extraction, you will take all the combined all the chloroform extract and you will combine this chloroform extract. After that you have to do the distillations of chloroform extract to evaporate the chloroform, and due to which you will get the dry residue of glycyrrhetinic acid. Okay, it is the white crystalline powder which is insoluble in water and soluble in the organic solvents like chloroform, benzene, ether, etc. So that it is the extraction procedure, but in extract there may be some there may be the presence of some impurities and other components may be there. And further, if you want to do the isolations of the glycyrrhetinic acid, so with the help of the column chromatography we can isolate the glycyrrhetinic acid, and after getting the isolated product, the structural elucidations we can do with the help of the spectral analysis. In spectral analysis we can do we can use so many techniques like UV, IR, NMR, mass. So with the help of these spectral analysis we can elucidate the complete structures of isolated component. And after isolating the component, so we have to find out the we have to identify the component, whatever the compound we got after isolation or after extractions method, so we can confirm by the identification test. So to identify the isolated product, firstly we can use the chemical test, that is Lieberman test, and second one is Lieberman-Burchard test. And with the help of thin layer chromatography we can also identify the this glycyrrhetinic acid. So to perform the chromatography we have to use the mobile phase, that will be toluene, ethyl acetate and glacial acetic acid in the ratio of 12.5 is to 7.5 is to 0.5, and 1% vanillin sulfuric acid we will use as a detecting agent, and we will compare with the standard drugs. What will be the standard drug? Standard drugs will be the glycyrrhetinic acid, and the RF value of glycyrrhetinic acid is commonly 0.41. So whatever the constituents we obtained after extractions and isolation, so we will compare with the standard drugs, and we will in this manner we can identify the isolated component. And if you see the chemical test, so first one is the Lieberman test. So as per the monograph we will take the required quantity of the sample, and to which we will add the acetic anhydride, and after mixing this we will heat the mixture followed by the cooling, and then we will add few drops of the concentrate sulfuric acid, so due to which blue color is obtained in the Lieberman test. And second test is the Lieberman-Burchard test, in which we will take required quantity of the sample as per the monograph, to which we will add the chloroform and acetic anhydride. Then from the side of the test tube we will add concentrate sulfuric acid dropwise. So firstly the color obtained is red, then it convert to blue, and finally green color is produced in this Lieberman-Burchard test. So in such manner we can identify the isolated component. Now next phytoconstituent of today class is rutin, which is the flavonoid glycosides and quercetin. So it is the most important type, and commonly It is obtained from the whole plant of Ruta graveolens, which belong to family Rutaceae, and from the flowers of the Sambucus nigra, belonging to family Caprifoliaceae. Okay, and some other sources are also there, from which we can obtain the rutin, like Phagopyrum esculentum, which belong to family Polygonaceae. Then rhubarb is there. Botanical name of rhubarb is Rhium amodi, which belongs to family Polygonaceae. Then tobacco is there. Botanical name of tobacco is Nicotiana tabacum, which belongs to the family Solanaceae. Then Eucalyptus macronycha, belonging to family Myrtaceae. Then tea, Thea sinensis, from the family Theaceae. So these are the various sources, but commonly it is obtained from the Ruta graveolens, and because of this Ruta graveolens, it is known as the Rutin. Okay, so major source for the Rutin is the Ruta graveolens, and this Ruta graveolens belong to family Rutaceae. And if you see the physical properties, that it's occur in the form of the crystalline powder and yellow in color. Okay, it is yellow in color and it's occur in the form of the crystals. And if you see the chemistry of this rutin is that, so it is chemically quercetin 3 rutinoside. Okay, chemically it is quercetin 3 rutinosides, and if you do the hydrolysis of this compound, it will give a glycon quercetin and the sugars glucose and rhamnose. Okay, glucose and rhamnose, it will give glucose and rhamnose. So this portion is the a glycon part. A glycon means non-sugar part, and this one is the sugar part. So glucose and rhamnose. So we can say that in the structure there may be two sugar unit, that is glucose and rhamnose, and on hydrolysis it yields quercetin molecules, a glycon quercetin molecules, and glucose and rhamnose molecules. And if you see the solubility pattern of the drug, so it is soluble in the alkali and sparingly soluble in water, and its melting point is 180 to 189 degrees Celsius, and it is used as a vitamin P or capillary fragility factors. And if you see the isolation method of this rutin, so first of all we have to take the drug and we will convert into the powder form, then we will boil with the water. Okay, we will take the drugs, we will convert that drug in the powder form, then we will boil the drug with the for the sufficient time as per described by the official monograph, followed by the filtration. But filtration should be when the extract is hot. It should always filter during the hot conditions and followed by the cooling. ओके सबसे पहले आपने क्या करना है कि ड्रग कंपोनेंट आपने लिया, जो भी आप सैंपल रिक्वायर्ड क्वांटिटी है ऑफिशियल मोनोग्राफ के अकॉर्डिंग, वो आपने ड्रग लिया और उसको पाउडर फॉर्म में कन्वर्ट किया। कन्वर्ट करने के बाद आप उसको वाटर के साथ बॉईल करते हैं स्पेसिफाइड टाइम, जो आपका ऑफिशियल प्रोसेस आप फॉलो कर रहे हैं उसके अकॉर्डिंग। उसके बाद आप इसको फिल्टर करेंगे, बट क्या है कि आपको हमेशा ये हॉट कंडीशन में ही फिल्टर करना है। यदि आप कोल्ड कंडीशन में इसको, कूल कंडीशन में यदि आप इसको फिल्टर करने लगेंगे तो ये नहीं हो पाएगा, क्योंकि इसकी जो है प्रेसिपिटेट टाइप का फॉर्मेशन हो चुका होगा, जिसकी वजह से आप इसको फिल्टर नहीं कर पाएंगे। सो इट शुड बी फिल्टर ऑलवेज एट द हॉट कंडीशंस फॉलोड बाय द कूलिंग। नाउ the filtrate is subjected to extractions rapidly with the twice its volume of ether. Now what you have to do, that whatever the filtrate you obtained after filtrations, you have to treat that filtrate with the ether, and the quantity of ether should be double of the whatever the volume of this filtrate is there. You have to take just double volume of this solvent or filtrate and ether. And why we are extracting with the ether? Because ether is helpful to separate the chlorophyll and other lipid substances present in the sample or in the extract. So with the help of ether, so all these chlorophyll and lipid substances can be removed. Then after this treatment, the solution is concentrated. So we are extracting this one, and we will separate the ether layer. We will separate the ether layer, and solution is concentrate under the reduced pressure to small bulk and allowed to cool and stand for the several days. Now what we are doing that, so ether extract we are taking and we will evaporate under reduced pressure with the help of the distillations. So under reduced pressure we will do that distillations, and we will evaporate all the ether. Then we will allow it to for cooling and stand, and we will wait for the several days. So due to which the crude rutin is crystallized out, and then it is filtered off. So after few days you will observe that there will be the formations of the crystals of the rutins. So now we can again recrystallize the rutin crystals by taking 5 times of its volume methanol. With the help of methanol we can again recrystallize the rutin. So what we have to do that, we have to take the 5 times more volume of methanol, whatever the volume or extracts volume of these crystals or these extract is there. So we can use with the boiling methanol. So now we have to allow to stand at low temperature. Once again the product may be recrystallized from boiling water, and once again recrystallize can be carried out with the help of boiling water. So due to which greenish yellow crystalline powder is obtained. Okay, तो आपने क्या किया इसमें, यहाँ पे आपने सबसे पहले ड्रग सैंपल लिया, उसको आपने पानी के साथ बॉईल किया. बॉईल करने के बाद आप इसको हॉट कंडीशन में फिल्टर करेंगे एंड फॉलोड बाय द कूलिंग. कूलिंग करने के बाद आप इस फिल्टर को ईथर के साथ एक्सट्रैक्ट करते हैं. और ईथर के साथ हम एक्सट्रैक्ट क्यों कर रहे हैं, टू रिमूव द क्लोरोफिल एंड अदर लिपिड सब्सटेंसेज. अब आप ये जो ईथर सॉल्वेंट है आपके एक्सट्रैक्ट्स में, इसको इवेपोरेट करेंगे अंडर रिड्यूस्ड प्रेशर. उसके बाद हम कुछ दिन तक इसको ऐसे ही छोड़ देते हैं. तो आप कुछ दिन बाद ऑब्जर्व करेंगे कि देयर विल बी फॉर्मेशंस ऑफ द क्रिस्टल्स ऑफ द रूटिन. एंड इसको दोबारा से रिक्रिस्टलाइन करने के लिए हमें क्या है कि 5 टाइम्स मोर वॉल्यूम लेना है मिथेनॉल का, बॉइलिंग मिथेनॉल का. उसके साथ हम बॉयल करके इसको फिर स्टैंड करेंगे एट लो टेम्परेचर में. हम इसको वेट करेंगे, तो उससे भी जो है आपका रिक्रिस्टल फॉर्मेशंस होता है, मतलब और अच्छे आपके क्रिस्टल्स ऑब्टेन होने लगते हैं. और तीसरी बार आप अगेन इसको जो है दोबारा से क्रिस्टलाइजेशन कर सकते हैं विद द हेल्प ऑफ बॉइलिंग वाटर. तो लास्टली जो आपको मिलेंगे वो ग्रीनिश येलो क्रिस्टलाइन कलर के, येलो कलर के आपको क्रिस्टल्स रूटिन के ऑब्टेन होते हैं. फर्दर यदि आप इफ यू वांट टू structure elucidate of isolated compound, so you have to do the spectral analysis, because whatever the phytoconstituents you are isolating, always you have to determine the structure, or you have to elucidate your isolated structure with the help of the spectral analysis. So IR, UV, NMR, mass is the common spectral techniques. With the help of these techniques we can elucidate or we can confirm the structures, and whatever the phytoconstituents we are obtaining we can confirm by the following test, like Hinoda test is there. So what we are doing that in Hinoda test, that we will take the required quantity of the sample, to which we will add 95% of ethanol and concentrate sulfuric acid and magnesium turnings. So due to which orange, red, pink to purple color may be obtained. And with the help of thin layer chromatography we can also find out, or we can also confirm the presence of rutin, in which we have to take the mobile phase 10% aqueous sodium chloride solution, and standard drug rutin we will take, and we will compare with the standard drugs, that is rutin. And the RF value of standard rutin is 0.43, and if you perform the TLC of drug, so yellow spots is there. So with the help of this TLC you can also confirm the presence of the rutin. So it was all about the today class, and so you have to find that the general method of these are the general method, but if these component you have to isolate in the industrial in industrial pattern, or you can say that how we can obtain this in industry. So basic principle will be same, and there will be the large devices, and in large scale these phytoconstituent can be isolated from the industry for the commercial use, and by but the principle will be same. So thank you very much for watching this video.